Hey guys, so today we're going to do our second lesson of this chapter, which is all about area of overlap. So area of overlap is the area that's covered anytime you have two different 3D shapes that are touching each other or are joined together. So for instance, if I have a shape like this, the area of overlap would be where this rectangular prism that is my little agenda touches the bottom of my nail polish. That is the area where they are overlapping one another. And in order to identify the area of overlap, first you need to break the composite object into simpler shapes and then identify where they're touching each other. So for example, if we look at this shape here, I have a cylinder sitting on top of a poorly drawn rectangular prism. And so the area of overlap is the area where they are touching each other. So in this case, that would be just wherever the bottom of the cylinder is. The bottom of the cylinder is touching the top of the rectangular prism. So that is an area of overlap. And so if we were going to calculate the area of overlap, in this case, that area that is overlapping is a circle. It is the circle that is the bottom of that cylinder. So the formula that we're going to use is pi r squared. So we're told that the diameter of this cylinder is 4, and so that means that the radius is going to be 2. And so 2 squared is 4 times pi is 12.566. I haven't put units here, but whatever, units squared. For the next example, I have a shape that I haven't actually broken apart into different simple objects yet. But if you look at this face right here, this is not a simple shape. And so before I start here, I would need to essentially break this face into a rectangle and a triangle, which means I have essentially created a rectangular prism here and a triangular prism here. And so the area of overlap would be where the rectangular prism and the triangular prism are touching, which would essentially be right in there. Okay, that's like inside where the triangular prism is up against the rectangular prism. And so to calculate that area of overlap, this time it is just a rectangle that we're dealing with in here. And so we'll just use length times width. And so this length here would be the same as this. So that is 15. And then this width is 10. So 15 times 10 is 150, whatever units, I'm going to say meters this time, squared, even though I haven't written in units for any of these. Okay, and then the last one is slightly more complicated only because we are having more than one area of overlap for this last one. Essentially, I have an area of overlap where this top cylinder overlaps with the cylinder underneath it. And I have another area of overlap where the middle cylinder overlaps with the one underneath it. So this time I have two areas of overlap. They are both circles, but when you have multiple areas of overlap, they don't actually need to be the same shape as each other. So I'm going to label this as area of overlap number 1. Again, it's very important to label what you are finding the area of if it's not obvious, if it's not just like one shape, which I have highlighted here. So in this case, we're back to using pi r squared. The diameter of this top cylinder is 3, which means the radius of this is 1.5. 1.5 squared is 2¼ times pi is 7.07-ish. And then I'm going to call this area of overlap number 2. It's also a circle, so pi r squared. This time, because the diameter of this cylinder is 6, the radius is 3. 3 squared is 9 times pi is 28.27. And so the actual final answer here, we would get by adding these two together. So the area of overlap is 7.07 plus 28.27, which is roughly 35.34 whatever units squared. Okay, so all you're doing is, again, looking at the shapes, seeing where the different simple shapes or simple 3D objects would be touching each other. That's your area of overlap. And then if there's more than one, you just add them together. Okay, that's all for today's lesson.